Hi, I'm Dr. Digestible. So we are continuing from the last place we stopped the last time, and we have been able to use MagMap to plot the radially average power spectrum. Now, the thing is, for most people, they don't even understand what this means. So, what I'm trying to do here is to take you back door and explain and give you an intuition of what all this means. This particular Geosoft program, Oasis montaj, has this data file that it has stored, and it's available in the directory or in the folder where you have your data. So what we're going to do, we're going to use Excel program to open this data and still plot it ourselves so that we understand what is going on behind this place. So we'll open up Excel, and the thing you're going to do is to go to data and get external data from text. So when it gets there, you navigate to where you have your folder and go to this place. Because it's a special file, you have to choose these all files here. Now the file that we are searching for is this .spc file. It's of the file type PKCS number 7 certificates. This is the file that was produced when you plotted the radially average power spectrum using Oasis montaj. So you click on the SPC file and click on import. Now we are going to check this delimited option here and go to next and use space. The delimiter is space, and you click next and just say finish and OK. So this actually imports the data that was produced when you plotted the radially average power spectrum. Now we're going to be doing a little house cleaning here and explain some of this data that we have here. So let me delete this, and maybe this goes, delete, and also let's take this one off here. We do not need it. So as it were, we are seeing about 5 columns of data here. Now let me explain what this means. It's important for you to know what this data means. This CYCK per unit represents the wave number. It's actually the wave number or cycles per meter for this particular column here, this first column. And this third column represents the spectral density or the power of the spectrum. And this power spectrum was used for all the elements in this wave number, so to determine the average that we have used here. Now this second column represents the number of elements that were used to determine this particular average. And it is important to notice that these 3 depth and 5 depth columns are the ensemble of magnetic depth estimates based on 3 and 5 point averages of the slope energy of the radially average power spectrum. So to better understand it, we're going to have to do a cross plot of this particular data so that you will get to see how the data looks like. But before then, let's copy this data. Let's copy this data and put it in a separate sheet to enable us to cross plot. So on column this down again, come to this place, we have to select this again. Okay, so this has been selected. So what we're going to do is to go to insert and use this scatter chart. Now what we are seeing here is something that mimics what Oasis montaj has plotted here. In fact, that is exactly what is happening here. Now it is important that you note that this energy that is here, because this is a plot of the energy versus the wave number in cycles per meter. This energy is we used the natural logarithm of this energy. Why did we do that, or why is it that it is plotted that way? It's important to notice that this particular approach mimics the natural power law spectrum, such that much energy comes from large deep sources where you have the lower wave numbers, and relatively little others will come from small or shallow, or the ones that have high wave numbers. So the depth sources here that you see are where you have the deeper sources, actually where you have the lower wave numbers. So it's important to note that. Also, we can, let's delete this and this. Also, it's important to notice that if you want to have an intuition of this, it's better we make these decimals to be at least maybe 5 or 6. So we'll go to format cells and use number. Let's make it at least 5 decimal places for us to see what's going on here. Like I said, this is the wave number, and for you to understand it, this particular cycles per meter here, which is the wave number, can actually be converted to wavelength or lambda. Now, how do you do that? This is actually equal to the inverse of the wave number. So we do 1 divided by this. Of course, 1 divided by 0, it's not possible, but we just take it for all that. So you can see where you have the longer wavelengths is actually where you have the deeper sources. So for us to have some form of trial, for us to know what is going to happen when we plot the slopes, because the slopes actually give the depth estimates from this place. Because this particular method was taken from the classical approach of Spectral and Grant in 1970. So depth to the top of these sources, the slope of each of these line segments will provide the information on the depth to the top of the magnetic sources. Of course, these are just estimates. So now that we have been able to get this, it's important that we prepare our data in order to use the MATLAB program to estimate these depths. So we're going to copy this and copy this too, because this is what we're going to be plotting. Again, just let's copy it and create a new sheet here. Sheet 2, we paste it here. So this is what we are going to use for, and let's just save it. We'll save it as trial. Let's navigate to where we may have it. Let's save it as trial. So this is what we are going to be using, sheet 2 trial. So let's open up the MATLAB program in order to estimate the depths to the top of the magnetic sources. Now the best thing, once your MATLAB program is open, go to the folder where you have your folder and copy the path of the folder and paste it on this place, the path here, so that you have everything in one place. So the file that we're going to use to plot this power spectrum is this slope plot. So in this function area, you type slope plot and hit the enter key. Now this particular thing comes out. So you click on load data. When you click on load data, check the trial file. Now for the title, you name it appropriately. Remember, we used block 1. Now what is the sheet number? Remember, we are using sheet 2, and now we are going to map the x and the y axis. Remember, the x axis is the cycles per meter, which is the wave number. This has come up, while the y-axis is the logarithm of the energy of the spectrum, which is the natural log of P here, and you click on plots. Now this MATLAB program plots this for us. You see the title, this title says energy spectra of block 1, just like we have named it, and this is the frequency or the wave number in cycles per kilometer here, and this is the natural log of the spectral energy. Remember, just like Spectral and Ground said, much of the energy comes from the deeper sources, actually concentrated on these places with the lower wave number. So you have these crosshairs here. You click on this place and double click here to give you the depth estimate for the deeper sources. And now click on this process again here and check the slope of these particular sources here. This is very, very subjective, but you can try as much as possible so that you can get some depths that are reasonable enough. So this place is 2 kilometers, while this place is about 520 meters. So when you are done here, all you need to do is either you snip this or you actually copy this and save it as a particular JPG file or whatever file type that you prefer. You can use PNG, TIF, or any file type. So let's use JPG and save it that way, and of course it will show you whatever you have at the end of the day. So we are using block 1, we have saved it. So in order for you to present your results, it's important that you probably make a new sheet, have your x1 written. X1 is the longitude of the list of the longitude of the block, and you have the x2, that is the maximum of the longitude, and you have y1 as the minimum of the latitude, and y2 as the maximum of the latitude. Let's assume we use 6.0 to 6.5 here, and 9.0 to 9.5, remember, for block 1. So we have the deep sources here, deep sources, and we have the shallow sources here. So that is the depths in meters, in kilometers, depending on what you want to have. So here we had it to be 2.09. So 2.09 times 1000, if you want to live in a kilometer, so you have 2.09 here, and this other one is 0.522. Remember, these are in kilometers. So, and that essentially does it for you. So this will be done for the number of overlapping blocks that you have. Like I said, it's important to note that this particular program, this slope program, was written for MATLAB 2015. And once you have finished compiling, it will give you an estimate of the depths to the various sources, or depths to the top of the magnetic basement. Thank you, and God bless everyone.